Hello everyone, my name is Shaun Levick from the Gears Lab. Welcome to this introductory course to remote sensing of the environment. For today's prac, we're going to get started with the Google Earth Engine processing environment. To complete the lab, you will need to have signed up for an Earth Engine account. You can do so with this link. Once registered, you can access the environment with this URL. For those of you who are not familiar with the JavaScript programming language, that's the language that forms the basis of the Earth Engine environment, some of these basics are covered through this link over here. The objective of this lab is to give you an introduction to Google Earth Engine. By the end of the exercise, you'll be able to search, find, and visualize a broad range of remotely sensed datasets. We will start with single band imagery for simplicity. And for this, we'll make use of elevation data from the SRTM mission. That's the Shuttle Radar Topography mission. For those of you it's their first time in Earth Engine, this little map shows the breakup of the scene. I've opened my editor in this tab over here. So this is the default view when you first enter Earth Engine. You'll all be very familiar with the mapping interface that takes up most of the screen. This is the same type that we have in Google Maps and Google Earth. So you can use the left mouse button to pan, and you can zoom in and out with the wheel of your mouse. We also have some zooming tools over here, and we can switch between the satellite and map view over here. This section we have our scripts, our docs, and our assets. Over here is the inspector, the console, and the tasks tab. The centerpiece here is for writing our scripts. If we go back to the tutorial, you'll see that there's a few more details here telling you what each of these sections is for. But we'll discuss these as we use them in the practical. So our first step in getting started with images, we're going to navigate to Darwin and zoom in using the wheel mouse. This is Darwin, right up top of Northern Australia. So if we zoom in here, we can come in, see Darwin and the surrounding areas. We often use Kakadu National Park for these tutorials. Step 2 is to clear the script workspace by selecting Clear Script from the Reset button drop-down menu. In all of these tutorials, I tend to highlight the section that we're working on in red ink. Now, if it's your first time in Earth Engine, your script is probably clear, but in case it's not, you just come over to the Reset button, click the drop-down arrow, and clear the script. Now we have a clean working space. Step 3, we want to load up some elevation data, and being Google, it's very search driven. If we want elevation data, we just type elevation into this search panel, and you'll see that it finds for us a number of raster datasets as well as some table datasets. We're going to choose the SRTM digital elevation data 30 meter. I'm just going to click on that, one left click, and that brings up some information about this data set. This is the Shuttle Radar Topography mission, and the reference for that is Farr et al. 2007. That's down here. Some details about the date range it was collected, the provider, NASA, USGS, JPL, some information about the processing that's been done, and a link to a more detailed technical document. What's nice is we also have some information here about the band structure. So there's only one band in this data set, and its name is elevation. The units are meters. The range of elevation values are from -10 to about 6,500. The spatial resolution is at 30 meters. We're going to click the import button here, import the dataset into the script, and you'll see it pops up here in our new script in the imports section. we go back to our tutorial, you'll see that we've done this step, clicking import, and we're now on step 5. When we bring in a data set, often it has a very default name like image. We're just going to rename that to SRTM so that we know which variable it is. Be very careful with spelling and cases as we go through these tutorials. Now, let's go on to step 6, and we're going to add the image object to the console by copying the script below into the code editor and clicking run. In all of these tutorials for the next few weeks, I've placed all the JavaScript code in these gray boxes, and you just need to copy them out of here. So we're starting very basic. Let's copy that, paste it in here, and all we're saying is that we want to print this variable to the console. The console's over here. If we click run, image is computing. This just brings up more details about the data we've actually added to our script. And we have some information here, like we can see that there's only one band in the image, and that's called elevation. Now, coming through to step 8, we want to actually add this data set to our map view. We're going to make use of the map add layer function. So we're going to copy this line of code, copy, paste. Be aware that each line in the syntax ends in a semicolon. So line 2, map add layer SRTM. It'll take you a while to get used to the syntax, but it is quite user-friendly. We want to add a layer to the map, so we use map add layer SRTM, and let's hit run. And you'll see our screen fills up in a gray color. At least we know that something has happened. There's no error in our script, otherwise an error would pop up here. And if we hover over this layers tab, we can see that we've added layer 1. We can flick that off and on. So something's here, it's just completely gray. Let's go back to our tutorial. Step 7, select the Inspector tab, then click on a few points on the map to get a feel for the elevation range in the area. The thing to remember is that what we're displaying here is a histogram stretch between the min and the max values, and this is a global data set. It ranges from 0 to over 6,000 meters above sea level. That's why it's completely a washed out gray. So let's get a feel for the values that we actually have in our scene. We can come over to the Inspector tab, that's over here, and as we click, we'll see an elevation value. So 103, 83, 100. So this is quite a low elevation area. So that means we can specify an elevation range. 323, getting a little bit higher. But if we were to go up to about 400 meters, I think we would cover it. So next line of code would then be map add layer SRTM. We want to add that same data set, but we're going to specify some visualization parameters. And what's actually in here is specifying a minimum value of 0 and a maximum value of 300. So let's copy that, just paste it in here, click run, and it still first loads up that first layer we told it to, but now we're adding a second layer, and now we can actually see some detail in the scene. Areas in black are low lying, close to sea level. Areas in white are much higher. This here is the Arnhem Plateau in the Kakadu region. So that looks a lot better. You'll now be able to see variation in elevation range. And you also notice that layers added to the map have default names like layer 1, layer 2, etc. If we come back here, you see the second layer we added is called layer 2, and this is layer 1. Also just take note that we have some nice transparency tools here. We can adjust the transparency of these layers. But if we want this to be more human readable, we can add a title and give a description to these layer names. Let's copy in our next line of code from point 9, and we'll read this out in the editor. Map add layer, SRTM, define the min and the max range. And you'll see here I've just inserted elevation above sea level, this piece over here. And this is giving a title to the layer now. So if we click run, we should now have 3 layers because we've added 3 map layers. And we'll see that here. Layer 1 is the gray layer without visualization parameters. Layer 2 was the one that we created with visualization parameters. And now this is the last layer we asked it to load. That's the SRTM data with the min and a max range, and you'll see that this name here matches what we specified up here. So that's great. It helps us organize our environment much better. But we should also clean up our code a little bit, and it's just good practice that as we're going through to write notes to yourself so that you can remember what each of these steps do. And also if you're sharing code with other people in your research group, it's good to comment it so that others know what you are doing. The way we do that in JavaScript is very easy. We just use 2 forward slashes, and whatever is after these forward slashes is not read by the processing engine. So it doesn't matter what we write here, but it's useful for writing notes to ourselves. So for example, this next command, print SRTM, is just printing details to the console. This next line, the aim of that was to add the SRTM data to the map. This next line, the point of that was to add SRTM to map and specify a elevation range. And our last line here, this one was just creating a layer title. And if you keep doing this throughout the tutorials that we'll be doing over the next few weeks, it'll just help you remember what each of these steps is for. When we get to a stage like this, it's also of course good to save the script. Step 11, save as. So when you come here, you can just click on the little drop down arrow, save as, and you can create different repositories for different studies. You can do that by clicking on, if I just quickly come out of here, clicking on this red button here, new. If you create a new repository for this course, then when you save a script, it will be saved to that particular course. I'm going to call this Lab 1 Intro, for example. Save it. Now, under my owner folder over here, Lab 1 Intro, if I shut down the computer, exit the browser, when I come back in, I can just click on the script and everything will be here, ready for me to use. Just a couple of extra things I'd like to cover today is we've been through the visualization for defining the parameters. But of course, we may not just want a black and white image. So step 12 is if you'd like to experiment with different color combinations, you can play with color palettes. And what I'm going to do here is copy out this line and paste it in here. And let's write a note to ourselves. The point of this is to create a color scale. And let's just read through with me. So you'll see that in each line, we've just added a little bit extra. So all you really need is the last line. These are just here to remind you of what we've done. We're adding SRTM data to the map. We're defining a min and max range. We're specifying a title for the layer. And now this is the piece we've added. Now be careful. This needs to go within the curly brackets of the min and the max, because this is part of the visualization parameters. All our visualization parameters occur between these curly brackets. And let's see what I've done. I've specified a palette, and I've said blue, yellow, red. Now all this means is that when I hit run, it's going to generate the same layers again. We're now up to 4 layers. We've called these two the same, but the one on top is the one with the colors. And as that loads up, you'll see it's now colored from blue to yellow to red. And it would be very easy to change these. For example, if we just typed in green over there and ran that again, it would load up, and this goes in order from lowest through to highest. We can change that back to red. So you can play around with that. You can add in multiple colors to create nice visualizations. Number 13, for better visualization, we may also want to create a hill shaded view of the elevation data. As it sits here, it's quite two-dimensional. I mean, we can see the shape in the landscape, but we don't really have a texture. Often in our GIS, we would perform a hill shade analysis, which sort of simulates what sunlight falling on the landscape would look like. Now, the way to do that in Earth Engine is to make use of this command, Earth Engine Terrain Hill Shade. And if you come over to the Docs tab over here, we're going to cover a lot more of these in the course, but these are the huge range of functions possible in Earth Engine. And this one here, Earth Engine Terrain, these are different things we can do with terrain data. We can calculate aspects, we can look at hill shades, we can calculate slope. What I want to do now is create a hill shade. So if you just copy in these 2 lines now, copy both of them, let's read them. Variable, so we're creating a new variable. We're creating a variable called hillshade, and we apply the function hillshade to the SRTM data. We're then going to map add layer hillshade with a min and a max. This range, it's a grayscale image, so it'll range from 0 up to 255. If we want to exaggerate the features, we can reduce that minimum value. I mean rather increase it from 0 up to 150, for example. And we're going to call this layer hillshade. So I'm going to copy that, paste it in here. But before I run, I'm just going to make a note of what I'm doing. So when I'm creating and adding the hillshade. Let's run, see if that works. We don't get any errors. So all these layers are loading up. And we'll see that our hillshade is here, and it's loaded up nicely. If we zoom in a bit, Let's come over here. Takes a while for the different layers to load. Here's that Arnhem Plateau again. You can see the fractures in the rock. As our last layer comes up, you can see that hill shade over the top, and that really allows us to see the texture. And what's really nice is if we just adjust the transparency slightly, if we pull this through, you're able to see what's underneath. So we can play around with that. And if we just run this again, what I would suggest is that you can turn off some of these earlier layers just by adding the 2 forward slashes. Now we're actually only asking it to load 2 layers, the colored SRTM and our hill shade view. So there we have our colored elevation range with the hill shade on top. And if I just adjust that transparency, we have a nice 3D textured map. To really illustrate the power of Earth Engine though, the beautiful thing is that we can just zoom out, and although we've been working up in Darwin, this data set covers the whole of Australia, Indonesia, covers the whole world. So this is a global map of elevation mapped at 30-meter resolution with the hill shade across it. So the real advantage of this type of environment is that anything we do locally can be applied globally if we have a global data set. And that's really powerful for all types of environmental applications. Let's head back to Darwin. Last thing I want to cover today is that number 14, slope. We can do this in a very similar way. Create a new variable called slope using the Earth Engine function terrain slope, and the input is our SRTM data. Map add layer slope, that's the variable we created. Define a min and a max and call the layer slope. So we'll copy that, paste it in here, make a note to ourselves. Calculate and add slope to map, and let's zoom into a smaller area. Let's go around Catherine this time, Catherine Gorge, and hit run. There's our elevation. Here comes our slope. And we should have slope, hill shade, elevation. And we can play around with the different visualization parameters. We can add slope. We can adjust that to see how the steep slope is on those ridge areas. All right, that's all I have for you today. Just an introduction to how these tutorials will be running. Every week from now on, there will be a new TUT posted covering fundamental concepts in remote sensing. Keep an eye on my YouTube channel. I've created a new playlist for this set of introductory videos, and you can also find them on my Gears website. So thanks very much for your time, and see you next week. Cheers.